In this lesson, we're going to take a look at context-level attributes, as well as some thread safety when we start working with servlets and attributes at the context level. So here we have City Manager Web Attributes and Thread Safety.war. That's our file that's going to be set up the way that we're going to be at the end of this demonstration with all of this code. So you'll need to import that to go along with this video, and we'll make some modifications as we go to just do a couple quick different demos. So go ahead and get that from your resources file. And in that, what we'll find is that we've added an index3 file, which is going to be essentially a web page that just gives us a choice so that we can take some different options. And that will post to the threadsafe get seed servlet, and that threadsafe get seed will then do some things and drive us to the specific operation that we selected, either non-threadsafe servlet, threadsafe request, or threadsafe servlet. And threadsafe request is the one that we'll start with. So let's go ahead and expand our code here and take a look at what's going on. Here's our index. It's just going to post to the threadsafe get seed, and it's going to give us a choice of whether or not we want to look at request level, non-threadsafe, or threadsafe operations. So threadsafe get seed, when we enter this, we're going to see that we have a first pull to get the string from what the user selected into the do threadsafe, and then we're going to get an initial seed, which is going to be a init parameter from our web. So we can look at our web XML file here, and we can see the initial seed is set to 2. So we're good to go at 2, and then we'll just do some factors of 2, and we'll see that in the code in a second. And then once we have that, we're going to immediately set that seed into the servlet context attribute. Now, we saw request attributes before, and now we're seeing servlet context, and they have attributes as well. Well, what's the difference? Well, the request attribute lives on the request object, so as soon as that request is gone, that attribute is gone. With the servlet context, we're actually looking at an entire application level parameter here that we can use across multiple requests, and that's very powerful, but also opens the door for the problem that we have multiple people using our website, and thereby we need some thread safety. And you might also be taking just 1 second to think, why is it named servlet context if it's the application level? You're absolutely on track. Servlet context is the application level. The servlet context was named that way by whoever programmed it, and that's okay, because what we see is that everything we do in our container, a lot of it's actually going to be done in servlets of some type. But right now, we'll just assume that servlet context, and be right about the assumption, that servlet context is application level. Once we have that set, then we can go ahead and go to our different threads based on what the user's chosen, and that will take us to our different options. So the first one we're going to look at is request level. So we know that we have the request level, and we can actually set our variables and work with them at that request level. So the first thing we'll do here is grab the servlet context attribute that was just set in our initial seed there, and we'll multiply that by 2 to just easily see when things are modified. And then we're going to set the attribute into the request level. Now the way this ends up, we're going to stop with this at being a set before the long-running operation. We're going to comment that part out for now, and we're going to run this before. We're actually not going to update the attribute until after the long-running operation. So let's go ahead and uncomment this one. And so we're going to assume that long-running operation is something that we could be doing on our web page, hopefully not taking a full 5 seconds, but that 5 seconds gives us plenty of time to inject another thread and watch what happens. We'll then repull the attribute from the current seed from the request, as well as from the servlet context, and then we'll go ahead and print it all out and watch that as it happens. First, we need to save this, and then we'll go back to index 3, and then we'll run this. And what we'll see here is it'll give us a choice, of course, of which one we want to choose. So we're going to pick request level when this comes up. And we're going to go ahead and select execute, and it does take about 5 seconds each time we execute this to watch it happen, but that gives us, again, time to interact. So what we want to do is have a web page up and running and ready to go. So open up a web page, copy that URL, and then place that into the web browser and hit enter. And what we'll be able to see is that it was 244, and then hopefully this one will be 488, and it is. So it looks like things are working the way they're supposed to. So what happens if we run 2 people at the same time? Now we have multiple people using the system, 8.16.16, 8.16.16. Uh-oh, we don't have any thread safety. Nobody was claiming the value until it was too late. So both of them got the same value, which is a real problem if those values need to be unique. So what we can say is, oh, I know how to fix that. Instead of waiting until after the process completes, let's just write before the process completes. Sure, let's give it a try. So let's go ahead and turn this one back on, and go ahead and turn this one back off. Save that, go back to index 3, and run it again. And of course, every time we do this, we need to restart our server anyway, so that our seed will reset back to 2 for the context, and then we can easily track it. Once again, we'll select request level attributes and hit execute. And we'll let that one run. It takes about 5 seconds again, and then this one will be already on the right URL, so we can just go ahead and hit enter. 2, 4, and 4. And this one comes up 4, 8, and 8. That's looking great. Let's see what happens if we run concurrently. Now we get 2 people running at the same time, and 8, 16, 32, 16, 32, 32. We seem to be where we really need to be. If you really take a good look at it, that was 8, 16, and 16, 32. But if you were using that context attribute afterwards and it was supposed to be what you had just set to the request level, what happens in this one where it got set by the other person to 32 and it was supposed to be 16? So there's your big problem. So we're not really thread safe. Even though we could probably get away with this at some level, we need to be more careful. So what we want to do is think about how can we do this in one servlet so that everybody's hitting the same thing and we have a bunch of options to go ahead and see what's happening. So what we can do is select non-thread safe and take a look at this. Well, let's make a non-thread safe servlet, and we'll have this servlet basically handle everything. On this one, person will come in, we'll then go ahead and get from the servlet attribute. We won't even mess with the request attribute anymore. We'll just immediately write to the servlet request, and then we'll go ahead and get the information after it gets back and spit that out so we can see what's happening. So this non-thread safe servlet will run, again, in index just like the other one. Let's go ahead and run that. This time we'll choose non-thread safe. So let's expand this a little bit and we'll execute that, non-thread safe. And so we got 2 and 4. Let's go ahead and copy this value again so that we're in the right URL. And let's run it in another thread real quick. So now we can see this one should come up 4 and 8 since everybody was playing nicely. We're non-thread safe, so what do you suppose is going to happen when we execute multiple threads on the same servlet? 8 and 32, 16 and 32. So now, once again, everything was put in place sort of correctly. We had unique values at 8 and 16, but both of them came back as 32. And that's a real big problem if there's more concurrency that needs to happen afterwards with that initial value, which should have been 16 in this thread. So the one last thing that we can do then is say, well, how can we make our entire servlet thread safe so that it doesn't have this concurrency issue? Well, it's actually quite simple to do, although it does create another problem that we have to consider. So when we look at our code for the thread safe servlet, it's going to be exactly the same as the non-thread safe servlet. The only difference is going to be we're going to wrap it with a synchronized attribute, and that's going to wrap the servlet context. Now by doing this, we're basically going to say this synchronizes and locks this thread until it completes. And once this is done, then the next person that called it can run it. But you can already start to imagine what the issue might be with that if you have a longer running process on the web and hundreds of users trying to hit this at the same time. You'd end up with a huge bottleneck, right? Well, let's watch it happen, and let's see that it is, in fact, thread safe, but it does add that problem to our code. Let's go ahead and run our index one last time. And here we'll select thread safe, and we'll execute that. And again, it takes just a moment, and we'll pull up our secondary browser again so that we have another thread that we can simulate someone hitting this web page. Before we had 2 and 4, and here we have 4 and 8. So everything seems to be working as expected. Now what happens when we run concurrently? So what we'll see is as this runs, the first one will complete, 8 and 16, and then the second one actually starts its process. We have to wait a full another 5 seconds. So you can see that bottleneck was created by having that thread-safe synchronization. By having multiple processes running that are synchronized, we create a huge bottleneck, and our users would have to wait, especially if there are multiple users. So we have to weigh those possibilities and make sure that we're on track with performance as well as operation.